No alternating in this case, right? Yes.
Or do you consider it as a
Say it again.
Do I need to write a minus 3 to the power 3, or can I write a negative 7?
Either way in this case. I like breaking it into its elements in case it combines up with one of the power series pieces, which it doesn't in this case. You were attempting at the beginning though, right? How are we doing? Alright.
Stupid think.
So I want to introduce how to do some calculus with this.
Yeah, I'm done with the
We're going
algebra.
to start with the derivative. Yeah, no, we're not going to stick with the algebra. I'd like to show you why this works.
Did n increase?
Yeah, this little index increase here, we'll talk about that here in a second. All I did was take our original power series and write it out. This is if it's centered at 0. If it's not centered at 0, it's the same rule. Okay, the n comes down just like a regular power series or a power rule. Notice when I take the derivative. Notice where I start. A naught is a constant, right? Derivative of constant 0. And here's the extra n here. The 2, the 3, 4, 5, 6. This is where it gets a little hairy. We'll get the integral here in a second. power series representations for first degree denominators. Now we have the second degree. It's a little more involved. Do we understand the question at least? So I want to come up with a power series representation for this function. So I'm going to start here. I'm going to start with something I know. We already know that this is here. Because the geometric series. You with me? I'm going to take the derivative of this. You get a -1 that comes out in front, but the derivative there is also a -1. It's looking to me like the derivative of g of x is equal to the function we're looking for. We okay? We kind of lucked out. We didn't end up with a bunch of extra negatives or craziness like that. Every other one that we do from now on, we will have to manage that. But for right now, we don't. So I'm going to say g prime of x is also equal to g prime is equal to what we're looking for. So when I take the derivative of my power series, that should equal what I'm looking for. Take a minute and explain this to your neighbor. Verbalize it.
What am I explaining?
Everything.
When you take the derivative of
Okay.
it's equals to
You know the test
g of x.
right there, right?
Uh-huh.
The original function.
Well, if you do that to the g of x one,
The f of x equals
you would get that.
Yeah, I'm a little confused by this.
Same thing.
I'm wondering why we're doing it to the derivative and how the derivative is turned into that. And how that doesn't get turned back into... How does the derivative end up being their original? That's what I'm... Does that make sense?
It's the derivative function, the first one.
Yeah.
But the derivative of 1 minus x is -1 also. In this case, it can't get
So then they did the... Okay. Yeah. Check it out.
How do you get the derivative of that?
So we know the relationship between f of x and g of x. So f of x is the integral. I'm sorry, is the derivative of g of x. G of x is the integral of f of x. Up here, he gave us the definition of the derivative of this equals that. So we
Notice
know the
this
derivative
x
of one representation
it's still going to be raised to the 0 power.
I was just... He fixed the thing, that was confused with the minus one. I'm like,
See, x exclamation 0 power. There's the minus 1. I forgot the one. You doing okay? Let's do it a little bit more complicated.
Yeah, because I wasn't.